Traditionally, the process of deploying a new device begins with wiping the device with whatever operating system was pre-installed and deploying one of the organization's images to the device. However, when admins are purchasing a device from an OEM, Windows 11 is already the OS on the device. While simply using the OEM image isn't practical, Windows 10 introduced a new process called Windows Autopilot. Autopilot is designed to achieve the desired outcome of deploying a new hardware or refreshing an existing hardware with the organization's desired configuration, without the process of creating, managing, and pushing large images over the network. Objectives. After completing this module, you'll be able to explain the benefits of modern deployment for new devices. Describe the process of preparing for an Autopilot deployment. Describe the process of registering devices in Autopilot. Describe the different methods and scenarios of Autopilot deployments. Describe how to troubleshoot common Autopilot issues. Describe the process of deployment using traditional methods. Next unit, use Autopilot for modern deployment. Continue. Modern deployment methods take a new approach to provisioning devices. One of the key benefits of Windows 10 and later is a feature called Windows Autopilot. Windows Autopilot is a cloud-based deployment method. With Autopilot, you can set up and pre-configure new and existing Windows 10 or later devices. Users in your organization use a new operating system out-of-the-box experience, OOBE, to configure their devices without needing a Windows image. Autopilot offers the following advantages over on-premises deployment methods. You don't need to use images. You don't need to customize the deployments by injecting drivers. You don't need to deploy and maintain a deployment infrastructure. Configuring Autopilot deployments are relatively simple compared to traditional image creation and management. With no images to deploy, heavy bandwidth consumption is no longer a concern. Windows Autopilot is cloud-driven and based around Azure AD Premium and Microsoft Intune. Using Windows Autopilot, you can join devices to Azure AD automatically. Auto-enroll your users' devices into MDM services. Restrict the creation of the administrator account. Customize the OOBE content specifically to your organization. New devices. Most organizations purchase new devices from an original equipment manufacturer, OEM. In this process, they typically buy the device with an OEM license of Windows 11, usually Pro Edition. Organizations rarely desire the OEM image, and until Windows 10, they re-image the device to configure it to organizational requirements. It's no longer necessary to re-image the device when it already has Windows 11 or later. Regardless of the OEM image configuration or installed applications, Autopilot can reconfigure the device to suit the organization's requirements, including installing line of business apps and even changing the edition, such as switching from Pro to Enterprise. From the user's standpoint, turning on the device initiates an out-of-box experience, OOBE, during which the organization determines which options can be configured by the user. One potential benefit is the ability to have a zero-touch installation, ZTI, experience, meaning the device is ready to use simply by plugging it in and turning it on. Refresh existing devices. Over time, scenarios arise where it might be beneficial to refresh the device. Performance might be impacted as more apps are installed over time, and it can lead to intermittent issues or challenges that are not easily resolved. IT might elect to perform a wipe and load, and as with new deployments, Autopilot can be used instead of traditional methods. Similarly, if a device is reassigned to another user, Autopilot can be used to reset the device with a new OOBE as if the device was wiped and re-imaged. Windows 10 and later still supports traditional deployment. Many organizations use image-based deployment to upgrade their computers to Windows 11, although in-place upgrade is the recommended upgrade path when upgrading from Windows 8.1. Once a device is upgraded to Windows 11, organizations have the choice as to whether they continue to use image-based deployment or adopt modern deployment methods such as Autopilot or, in the case of upgrading from Windows 11, using feature update. Autopilot compared to traditional methods. The following table compares traditional and modern Windows 11 deployment. Expand table. Traditional deployment. Modern deployment. Deploys Windows 11 images. Yes. No. Can be used with any pre-installed operating system. Yes. No. Requires a previous Windows 11 installation. No. Yes. Uses an on-premises infrastructure. There are certain circumstances where traditional installation methods must be used instead of Autopilot. These scenarios include bare metal deployments. When the storage hardware where Windows 11 is installed must be replaced. In the event of a corrupted Windows 11 installation. When an organization requires prompts for custom user information beyond what the OOBE provides, such as customizing the LTI interface with MDT. Next unit, examine requirements for Windows Autopilot. Continue. You can deploy only known devices by using Windows Autopilot. When you purchase new devices, the hardware vendor can upload device-specific information on your behalf. If you want to use Windows Autopilot to deploy devices that your company already owns, you can transfer device-specific information to a comma-separated value, CSV, file by running a Windows PowerShell script and then uploading the CSV file to Microsoft Intune or Microsoft Store for Business. You can manage Windows Autopilot by using either Microsoft Store for Business or Microsoft Intune Admin Center. Before you can start using Windows Autopilot for Windows 10 deployment, you must meet the following prerequisites. Devices must have Windows 10 pre-installed. Windows Autopilot transforms an existing or Windows 11 installation by providing configuration settings to the OOBE setup phase. It doesn't deploy a Windows image, and the device must start to the OOBE setup. The device can be a new device with a pre-installed or later operating system that a hardware vendor delivered, or it can be an existing or later device that is configured to start the OOBE setup, for example, by using the System Preparation Tool, SysPrep. Windows Pro, Enterprise, or Education, Windows Autopilot can't deploy Windows Home or an operating system that is older than Creators Update, version 1703. Some features, such as Windows Automatic Redeployment or Autopilot for existing devices, require more recent versions. Devices must have internet connectivity. Windows Autopilot is a cloud service, and it can deploy the Windows 10/11 operating system only to devices that are connected to the internet. Furthermore, DNS name resolution for internet DNS names must be available, and access to all hosts via port 80, HTTP, 443, HTTPS, and 123, UDP/NTP. Organization must be using Azure AD. Azure AD is mandatory because Windows Autopilot depends on Microsoft Store for Business or Intune, and both of them require Azure AD. Windows devices that you deploy by using Windows Autopilot also automatically join Azure AD. If you want deployed devices to automatically enroll in a mobile device management solution such as Intune, the company must be using Azure AD Premium P1 or P2. Intune or Microsoft Store for Business. You can upload device-specific information in Intune or Microsoft Store for Business and configure a Windows Autopilot deployment either in Intune or Microsoft Store for Business. Because of that, your organization must be using at least one of those cloud services. Intune or another mobile device management service, optional when Windows Autopilot deploys Windows devices, it automatically joins them to Azure AD. If you want to manage such devices, you can configure Azure AD to enroll joined devices in Intune or another mobile device management service automatically. Windows Autopilot uses cloud services to configure your devices. These cloud services must be accessible from your registered Windows Autopilot devices. The following URLs need to be accessible: go.microsoft.com, login.microsoftonline.com, login.live.com, account.live.com, signup.live.com, licensing.mp.microsoft.com, licensing.md.mp.microsoft.com, ctldl.windowsupdate.com, download.windowsupdate.com. Next unit, prepare device IDs for Autopilot. After you meet all the prerequisites, you can set up Windows Autopilot deployment. The setup process includes obtaining the hardware IDs of the devices that you want to deploy to the cloud service, uploading the hardware IDs, creating a Windows Autopilot deployment profile, applying the Windows Autopilot deployment profile to the devices or device groups. Manage Windows Autopilot in Intune. If you want to manage Windows Autopilot in the Intune, you must configure automatic mobile device management enrollment of Azure AD member Windows 11 devices. You can configure automatic mobile device management enrollment by performing the following steps. In the Azure portal, select Azure Active Directory. On the Azure Active Directory blade, select Mobility, MDM and MAM, and then in the Details pane, select Microsoft Intune. On the Microsoft Intune blade, in MDM User Scope, select All if you want all users to be able to enroll their devices to mobile device management. If you want only some users to be able to enroll their devices to mobile device management, select Some, specify the groups whose members should be able to enroll, and then select Save. As discussed earlier, you can create Windows Autopilot deployment profiles in the Microsoft Intune Admin Center. Prepare a Microsoft Autopilot deployment. You can manage Windows Autopilot deployment by using Intune, Microsoft Store for Business. Note: Microsoft Store for Business is a cloud service that organizations of any size can use. Organizations use it to distribute both modern Windows apps that vendors develop for a general audience and line of business (LOB) apps that are available only for the organization ***. You must perform the first step, uploading device-specific information, including hardware IDs, in Microsoft Store for Business or Microsoft Intune. If you plan to manage Windows Autopilot in Intune, you'll have to sync Windows Autopilot devices from Microsoft Store for Business to Intune. To deploy devices by using Windows Autopilot, you must first obtain the CSV file that contains the device-specific information. Get the CSV file from your OEM partner. If your OEM partner supports Windows Autopilot, you can obtain a CSV file from them when you purchase the devices. You can also generate a device-specific CSV file yourself, based on the device inventory. The CSV file should have the following 3 columns: device serial number, Windows product ID, hardware hash. Generate your own CSV file. If the OEM partner doesn't provide a CSV file, you can generate a device-specific file by obtaining and running the Get Windows Autopilot Info.ps1 Windows PowerShell script. You can install the script by running the following command: install script name Get Windows Autopilot Info. After installing the script, you can generate device-specific Install script name Get Windows Autopilot Info. After installing the script, you can generate device-specific information and save it to the d:/devices/device1.csv file by running the following command. Get Windows Autopilot info.ps1 output file d:/devices/device1.csv. Upload the device-specific CSV file. To do this, you must have install script name Get Windows Autopilot Info. After installing the script, you can generate device-specific information and save it to the d:/devices/device1.csv. Install script name Get Windows Autopilot Info. Install script name Get Windows Autopilot Info. After installing the script, you can generate device-specific information and save it to the d:/devices/device1.csv file by running the following command. Get Windows Autopilot info.ps1 output file d:/devices/device1.csv. Upload the device-specific CSV file. To do this, you must have the admin role in Microsoft Store for Business or Global Admin role in Intune. When you upload a CSV file, you'll receive a notification if the upload was successful and the number of devices that were added. If there was any error, for example, if the CSV file wasn't formatted properly or some devices were already in Microsoft Store for Business, you can download the CSV file with error information and URLs that point to detailed error descriptions, and then you can review the details. When you upload a CSV file, you can add devices to an existing Windows Autopilot deployment group, create a new Windows Autopilot deployment group for the devices, or add them without using groups. You can use groups when you want to apply the same deployment settings to multiple devices at once. To complete this process using Intune, use the following procedure. In Microsoft Intune Admin Center, navigate to Devices, Enroll Devices. Select Import. Browse and locate your CSV file. Import the file. After import is complete, select Device Enrollment, select Windows Enrollment, select Windows Autopilot, select Devices, and then select Sync. Refresh the view to see the new devices. Import a device hash directly into Intune. In certain circumstances, it might be beneficial to directly import the device hash into Microsoft Intune rather than generating the file, as shown above. This is often useful in testing scenarios or perhaps could be useful if you have a batch of machines that are being built by on-site technicians ready for users. The following example imports the device directly into Intune along with assigning a dynamic variable tag, Autopilot Devices, to an Azure AD group to ensure the device ends up in a specific group. Open a PowerShell prompt on the Autopilot device at the welcome screen. PowerShell. Copy. Install script name Get Windows Autopilot Info. PowerShell. Copy. Get Windows Autopilot info.ps1 online group tag Autopilot Devices assign. Next unit, implement device registration and out-of-the-box customization. Implement device registration and out-of-the-box customization. 100 XP. 5 minutes. Once device IDs have been uploaded, configurations are ready to be defined and applied to target devices. Create a Windows Autopilot deployment profile. Once device IDs have been uploaded, a Windows Autopilot deployment profile must be created. This profile specifies the settings that should apply to the devices that you deploy by using Windows Autopilot. You can create and use multiple deployment profiles with Windows Autopilot, but you only use a single profile to deploy each device. Using Intune, you can use the following high-level procedure to create a deployment profile. Sign in to Intune. Once device IDs have been uploaded, a Windows Autopilot deployment profile must be created. This profile specifies the settings that should apply to the devices that you deploy by using Windows Autopilot. You can create and use multiple deployment profiles with Windows Autopilot, but you only use a single profile to deploy each device. Using Intune, you can use the following high-level procedure to create a deployment profile. Sign in to Intune as a global admin, and in the portal, select Device Enrollment, select Windows Enrollment, select Deployment Profiles, and then select Create Profile. Provide a name and description. Then, for deployment mode, choose between user-driven and self-deploying. With the former, the user specifies credentials during deployment, and devices with this profile are associated with the user account. With the latter, user credentials aren't required to enroll the device, and devices with this profile aren't associated with the user account. Next, configure the out-of-box experience OOBE settings, which include language, keyboard, EULA, privacy settings, and user account. Finally, create the profile. The autopilot deployment profile is now available to assign to devices. Apply a deployment profile. Next, the deployment profile is applied to a device or a group of devices. Until you apply the deployment profile, Windows Autopilot doesn't manage the OOBE setup phase on the device. After you apply the profile, Windows Autopilot takes control of the OOBE setup phase on the devices to which you apply the profile. You can use the following high-level process to apply the profile. Sign in to Intune as a global admin, and in the portal, select Device Enrollment, select Windows Enrollment, select Deployment Profiles, and then choose a profile. Choose Assignments, and then select the groups that you want to assign the profile to. After the setup process is complete, you can turn on the devices, and Windows Autopilot manages their OOBE setup phases. Compare the default and Autopilot OOBE experience. When employees turn on a computer that a hardware vendor has delivered, the OOBE setup phase occurs. During this phase, the Windows operating system asks for several configuration settings, such as: what is your preferred keyboard layout? Do you accept the Microsoft software license terms? Should the computer join ADDS or Azure AD? Which privacy settings should you use? These settings can be confusing for employees, and therefore, they often call the help desk or they misconfigure Windows. With traditional, custom image deployment, you can pre-configure those settings so that employees can't view or configure them. However, when a hardware vendor delivers a computer directly, the default Windows image is used, and the employee has to provide all of the configuration settings. An employee who completes the OOBE also becomes a member of the local administrators group, which can cause many problems. The default OOBE setup phase. The OOBE setup phase with Windows Autopilot. Windows Autopilot puts administrators in control of the entire OOBE setup phase for known Windows devices. After administrators identify devices by their hardware IDs, they can create and apply a Windows Autopilot deployment profile to those devices. When the devices start and have internet connectivity, they connect to the Windows Autopilot cloud service, ask the employees for their company credentials, and apply settings from the Windows Autopilot profile. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Feedback. Windows Autopilot supports several deployment scenarios depending on the desired experience. Windows Autopilot User-Driven Mode. Windows Autopilot Self-Deploying Mode. Autopilot for existing devices. Windows Autopilot for pre-provisioned deployment. Windows Autopilot Reset. User-Driven Mode. Windows Autopilot User-Driven Mode is designed to enable new Windows 10 or later devices to be transformed from their initial state, directly from the factory, into a ready-to-use state without requiring that IT personnel ever touch the device. The process is designed to be simple so that anyone can complete it, enabling devices to be shipped or distributed to the end user directly with simple instructions. Unbox the device, plug it in, and turn it on. Choose a language, locale, and keyboard. Connect it to a wireless or wired network with internet access. Specify your email address and password for your organization account. To enable user-driven mode for Azure Active Directory join, the following actions must be taken as part of preparing the Autopilot deployment. Users must be able to join Azure AD. If using Intune, and not Microsoft Store for Business, user-driven mode must be selected in the Autopilot profile assigned to the device if using Intune. The Autopilot profile must also be assigned to an Azure AD device group. The device must be added to Windows Autopilot and a profile must be assigned to the device. User-driven mode is also supported for hybrid Azure Active Directory join. In addition to the actions above, the following steps must also be taken. The device must be running Windows 1809 or later. Hybrid Azure AD joined must be specified as the selected option under Join to Azure AD as in the Autopilot profile. The device must be able to access the internet and an Active Directory domain controller. The Intune connector for Active Directory must be installed. This performs the on-premises AD join instead of requiring user permission to join. Self-deploying mode. Windows Autopilot self-deploying mode enables a device to be deployed with little to no user interaction, achieving a ZTI experience with all OOBE prompts pre-configured. The enrollment status page will display while the device is being configured, and then the computer will either complete and display the sign-in screen, ready for Azure AD credentials. If the device is configured as a kiosk device, it will automatically sign in by using a locally configured account. To perform a self-deploying mode deployment using Windows Autopilot, create an Autopilot profile for self-deploying mode with the desired settings. In Microsoft Intune, this mode is explicitly chosen when creating the profile. Note that this mode isn't available using the Microsoft Store for Business. Ensure that the profile has been assigned to the device before attempting to deploy that device. Self-deploying mode requires devices with TPM 2.0 and Windows 10 version 1903 or later. Some interaction might be required under certain circumstances. If only wireless, install the required modules. Copy. Autopilot for existing devices. As discussed previously, the Re-image and provision a 8.1 device for Windows Autopilot user-driven mode using a single, native Configuration Manager task sequence. This process allows a device that was traditionally managed with images to transition to device using modern methods. In order to facilitate this, a special task sequence must be used to deploy the image to the Windows 8.1 device, which includes delivering a configuration file associated with an Intune profile. The profiles must be created in Microsoft Intune before the configuration files are created. Once the profiles are set up, use PowerShell Administrator to create the configuration file. Install the required modules. Copy. Install module Azure AD. Install module Windows Autopilot Intune. Import module Windows Autopilot Intune. Sign in to Intune. Connect Autopilot Intune. Retrieve the Autopilot profiles associated with your tenant $Autopilot profile equals get Autopilot profile. Create a JSON configuration file for each profile. In this example, each file name is the name of the profile. $Autopilot profile for each object. $convert to autopilot configuration JSON. Set content encoding ASCII \desktop $.displayname.json. Save one of the profiles to an ANSI encoded file named autopilot configuration file.json. This file name must be used. Once the configuration file is created, you can create the task sequence in Configuration Manager using the following steps. Add the desired OS image to Configuration Manager. Create a package containing the autopilot configuration file.json configuration file. Create a task sequence using the Deploy Windows Autopilot for existing devices option. Configure the task sequence as needed. Be sure that the following are set. Enable partition and format the target computer before installing the operating system. Select the option to join a workgroup. Sysprep will fail if joined to a domain. Select the option Do not install any software updates. On the system preparation page, select the package containing the autopilot configuration file. For Windows 1903 and 1909, if using Configuration Manager's built-in template for Windows Autopilot existing devices task sequence, you'll need to disable the Prepare Windows for Capture step and add a new Run command line step that will run c:\windows/system32/sysprep/sysprep.exe/oops/reboot. This prevents Sysprep from deleting the autopilot configuration file. Complete the task sequence wizard. Note: devices should not already be registered with the Windows Autopilot service. Windows Autopilot for pre-provisioned deployment. Starting with Windows 10 version 1903, Windows Autopilot can also provide a capability that enables partners or IT staff to pre-provision a Windows PC so that it's fully configured and business ready. From the end user's perspective, the Windows Autopilot user-driven experience is unchanged, but getting their device to a fully provisioned state is faster. Instead of the entire provisioning process occurring when the user powers on the device, the provisioning process is split. Time-consuming portions such as device and user application installs and policies are completed by IT. Final user settings and policies are applied when the user connects and powers on the device. The process for configuring a pre-provisioned deployment is as follows. Enable the Windows Autopilot for pre-provisioned deployment option in the desired autopilot profile. Connect Ethernet required for pre-provision and boot the device. At the first OOBE screen, press the Windows key 5 times. In the additional dialog options, select Windows Autopilot provisioning. Verify the device information. If changes are needed, complete them in Intune and select Refresh to re-download the updated information. Select Provision to provision the device. When the process is complete, select Reseal. The device can now be delivered to the user. When the user receives the device, they simply need to connect and power on the device, select regional and keyboard settings, select a Wi-Fi network if applicable, and sign in. Pre-provisioned deployment requires Windows 1903 or later and an Intune subscription. The device must also support TPM 2.0 and device attestation. Virtual machines aren't supported. Access to the on-premises domain isn't required in the pre-provision process. Internet connectivity, or connectivity to a domain controller is using hybrid Azure AD join, is required during the final user process. Tip: the advantage of pre-provisioned deployment enables an administrator to install the bulk of applications, which are machine-targeted, leaving only applications specific to the user onboarding to complete the process. This can drastically reduce the time to provision the device and improve the user experience. For more information on pre-provisioned deployment, refer to Windows Autopilot for pre-provisioned deployment. Windows Autopilot Reset. In many environments, you regularly need to reset devices to their initial states after they've been in use for some time. For remote reset. Many environments, you regularly need to reset devices to their initial states after they've been in use for some time. For example, an organization might provide temporary employees with Windows devices, which the organization must reset for every new user. Organizations must also reset the computers in training rooms after each class. With traditional deployment, you would need to redeploy the Windows image each time you reset a device to its initial state. Windows Autopilot Reset enables you to achieve this goal without redeploying a Windows image. It removes all personal files, apps, and settings, and it resets a Windows device to its initial state from the lock screen. It can also deploy organizational apps and settings by using Intune or another MDM solution so that a device is ready to use after the Windows Autopilot reset. Windows Autopilot Reset supports two scenarios: local reset, remote reset. Local Windows Autopilot Reset. Local Windows Autopilot Reset uses Windows Reset functionality. You can use local Windows Autopilot Reset regardless of how you're currently managing a device. It preserves device name, Azure AD membership, and MDM enrollment. By default, local Windows Autopilot Reset is disabled in Windows, which helps ensure that it doesn't start by accident. To enable local Windows Autopilot Reset, you must set the Disable Automatic Redeployment Credentials policy to 0, false. After enabling local Windows Autopilot Reset, you can start it by pressing Ctrl plus Windows logo key plus R when you're at the Windows lock screen. Only users with administrative permissions can start local Windows Autopilot Reset. Remote Windows Autopilot Reset. To initiate a remote Windows Autopilot Reset, you can leverage an MDM service such as Microsoft Intune. This method eliminates the necessity for IT personnel to physically visit each individual machine in order to commence the reset procedure. By following these steps, you can use Intune to initiate the remote Windows Autopilot Reset process. In Microsoft Intune Admin Center, navigate to Devices Windows. Select the device for which you want to initiate a remote Windows Autopilot Reset. Select More, the ellipsis, and then select Autopilot Reset to start the reset. Next unit, troubleshoot Windows Autopilot. When troubleshooting Windows Autopilot, it's important to verify the following key factors. Configuration: has Azure AD and Microsoft Intune, or an equivalent MDM service, been configured as specified in Windows Autopilot configuration requirements? Network connectivity: can the device access the services described in Windows Autopilot networking requirements? Autopilot OOBE behavior: were only the expected out-of-box experience screens displayed? Was the Azure AD credentials page customized with organization-specific details as expected? Azure AD join issues: was the device able to join Azure AD? MDM enrollment issues: was the device able to enroll in Microsoft Intune, or an equivalent MDM service? Troubleshoot Autopilot OOBE issues. If the expected autopilot behavior doesn't occur during the out-of-box experience, OOBE, it's useful to see whether the device received an autopilot profile and what settings that profile contained. Depending on the Windows release, there are different mechanisms available to do that. You can use the event tracing for Windows, ETW, can be used to capture detailed information from autopilot and related components. The resulting ETW trace files can then be viewed using the Windows Performance Analyzer or similar tools. Information about the autopilot profile settings is stored in the registry on the device after they're received from the autopilot deployment service. These settings can be found at hklm/software/microsoft/provisioning/diagnostics/autopilot. To see details related to the autopilot profile settings and OOBE flow, Windows adds event log entries. These logs can be viewed using Event Viewer, navigating to the log at Application and Services Logs, Microsoft, Windows, Provisioning Diagnostics Provider, Autopilot. The following events might be recorded, depending on the scenario and profile configuration. Expand table. Event ID. Type. Description. 100. Warning. Autopilot policy, name, not found. This event is typically a temporary problem, while the device is waiting for an autopilot profile to be downloaded. 171. Error. Autopilot Manager failed to set TPM identity confirmed. Result sad face error code. This event indicates an issue performing TPM attestation, needed to complete the self-deploying mode process. 172. Error. Autopilot Manager failed to set autopilot profile as available. Result sad face error code. This event is typically related to event ID 171. Windows Autopilot Diagnostics. Windows Autopilot can now aggregate many of the troubleshooting techniques listed into a more easily readable format to isolate issues that occur. This function can be executed from a PowerShell command directly on the device. Open PowerShell command and enter the following, except download prompts. PowerShell. Copy. Set execution policy bypass install script get autopilot diagnostics force get autopilot diagnostics online. Once connected to the tenant with an account that has appropriate credentials, through the Graph API extensions for Intune, a list of policies, apps, and status is displayed. Troubleshoot Azure AD join issues. The most common issue joining a device to Azure AD is related to Azure AD permissions. Ensure the correct configuration is in place to allow users to join devices to Azure AD. Errors can also happen if the user has exceeded the number of devices that they're allowed to join, as configured in Azure AD. Typically displayed on a something went wrong error page, the error code 801C0003 signifies that the attempt to join Azure AD was unsuccessful. Troubleshoot Intune enrollment issues. See this article for assistance with Intune enrollment issues. Common issues include incorrect or missing licenses assigned to the user or too many devices enrolled for the user. When encountering the error code 801800018, it's accompanied by an error page titled Something Went Wrong. This specific error indicates a failed MDM enrollment process. Troubleshoot device import. If you experience a scenario where importing a device CSV file results in no action and a 400 error appears in network trace with error body cannot convert the literal device hash to the expected type EDM binary error appears, the device hash within the file is either corrupted or the hash might not be properly padded in the file. To resolve this issue, a minor edit to the file might be necessary to ensure the device hash is in the correct format. For more information, see Troubleshooting Windows Autopilot, Level 100/200, and Troubleshooting Windows Autopilot. Next unit, Knowledge Check. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Feedback. Was this page helpful? Yes. No. English, United States. Theme. Light. Dark. As an IT administrator, you're considering using Windows Autopilot's self-deploying mode for deploying new devices in your organization. Which of the following is a benefit of this mode? It allows a device to be fully configured for company use, reducing the time IT must spend on deploying new devices. It requires manual entry of user credentials during device setup. It requires IT personnel to manually register each device. It increases the need for physical IT support during deployment. Reducing. Oh, you're preparing for an autopilot deployment in your organization and need to gather device hardware IDs. Which method can you use to obtain these IDs? Using a third-party software inventory tool. Manually checking each device's system information. Oh, you're preparing for an autopilot deployment in your organization and need to gather device hardware IDs. Which method can you use to obtain these IDs? Using a third-party software inventory tool. Manually checking each device's system information. Using the Windows Autopilot hardware ID script. Requesting the information from the device manufacturer. 3. You're troubleshooting a failed Now's Autopilot hardware ID script. Requesting the information from the device manufacturer. 3. You're troubleshooting a failed Windows Autopilot deployment. Which of the following steps would be most helpful in identifying the root cause of the failure? Reboot the device and attempt the deployment again. Check the event viewer for errors related to device enrollment. Viewer for errors related to device enrollment. Correct. The event viewer can provide detailed error messages related to device enrollment, which can be crucial in identifying the root cause of a deployment failure. Reinstall the operating system on the device. Physically inspect the device for hardware issues. Next unit, Summary. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Feedback. Was this page helpful? Yes. No. English, United States. California Consumer Privacy Act, CCPA, opt-out icon your privacy choices. Theme. Previous versions. Blog. Contribute. Privacy. Even with the ability to reset the existing Windows image with Autopilot, sometimes even that isn't necessary, especially with new devices purchased from an OEM. A new device typically starts with a fresh install of Windows, and what's typically needed is the correct edition deployed, such as Windows Enterprise or Education, correct configuration, and apps. When this is the case, dynamic provisioning can further simplify deployments. Dynamic provisioning uses a number of transforms to achieve this objective. Expand table. Name. Description. Windows subscription activation. With Windows subscription activation, users of Windows Pro can upgrade to Windows Enterprise without needing to enter a product key, nor perform a restart. Provisioning package configuration. By using Windows Configuration Designer, you can create configuration packages that you can deploy to users' devices that can be used to configure apps and settings on those devices. Microsoft Entra Join with automatic MDM enrollment. Using Microsoft Entra Join with automatic MDM enrollment, users enter their work or school account details and their device is automatically joined to Microsoft Entra ID and enrolled in MDM. The user's device is then configured for the organization's MDM policies. Objectives. After completing this module, you'll be able to describe how subscription activation works. Describe the benefits of provisioning packages. Explain how Windows Configuration Designer creates provisioning packages. Describe the benefits of using MDM enrollment with Microsoft Entra Join. Next unit, examine subscription activation. Continue. Activating a Windows subscription is necessary to comply with licensing requirements. Activation links the Windows product key to a particular installation of Windows on a device. It assures software integrity and provides you with access to Microsoft support and a full range of updates. There are 3 main methods for activation. Retail. OEM. Microsoft Volume License. Microsoft Volume Licensing customers use Volume Activation Services to assist with activation tasks, which consist of Active Directory-based activation, Key Management Service, KMS, and Multiple Activation Key, MAK, models. Current volume activation methods. Enterprise environments use three main types of volume activation models and a service that runs on Windows Server 2016. You can use any or all of the options that are associated with these models, depending on your organization's needs and network infrastructure, including Key Management Service, KMS. This is a role service that you can use to activate systems within your network from a computer where a KMS host has been installed. By default, volume editions of Windows connect to a system that hosts the KMS service to request activation. No action is required from users. Multiple Activation Key, MAK. This method of activation uses product keys that can activate a specific number of computers. You can use MAKs to activate any Windows Volume Edition. Active Directory-based activation. This is a role service that allows you to use ADDS to store activation objects, which can help simplify the maintenance of volume activation services for a network. When you use Active Directory-based activation, you don't need a host server, as in KMS, and activation requests process during client computer startup. Subscription activation. Frequently, devices are purchased with Windows Pro already installed with a firmware embedded key. Traditionally, the machine needed to be re-imaged with the correct edition, typically Enterprise Edition. Subscription activation removes the need for this, transforming a Windows Pro device into a Windows Enterprise device, without the need to re-image and reboot the device. You can deploy Windows Enterprise E3/E5/A3/A5 licenses within your organization by using Windows Enterprise Subscription Activation or Windows Enterprise E3 in CSP and Microsoft Entra ID. You can deploy Windows Enterprise licenses in the following ways. Enabling subscription activation with an existing enterprise agreement, EA. If you're an existing EA customer, you can get Windows Enterprise E3 or E5 licenses for free, depending on your EA. Enabling subscription activation without an existing EA. You must purchase the licenses from a cloud solution provider, CSP, before you can assign them. Subscription activation requirements. To implement subscription activation, your organization must meet the following requirements. Windows Pro/Pro Education/Enterprise/Education is installed and activated on the devices you want to upgrade. An instance of Microsoft Entra ID is available for identity management. Devices to upgrade are either Microsoft Entra Joined or Microsoft Entra Hybrid Joined. For education, the education tenant must have an active subscription to Microsoft 365 with a Windows Enterprise license or a Windows Enterprise or Education subscription. How subscription activation works. With subscription activation, users can upgrade their devices from Windows Pro to Windows Enterprise without entering a product key, and without requiring the users to restart their computers. Subscription activation is possible with Windows Pro or Windows Enterprise. Your organization requires either an EA or a Microsoft Products and Services Agreement, MPSA. When a licensed user signs in using Microsoft Entra credentials that are associated with a Windows 11 Enterprise E3/E5 or a 3/A5 license on a device, which meets the above requirements, the operating system switches from Windows Pro to Windows Enterprise. All the appropriate Windows Enterprise features are available. When a user's Microsoft Entra subscription expires, or you transfer the subscription to another user, the Windows Enterprise device reverts back to Windows Pro Edition. This occurs after a grace period of up to 90 days. An Enterprise E3 subscription via a CSP. Windows Enterprise E3 in CSP delivers, by subscription, exclusive features reserved for Windows Enterprise Edition. Windows Enterprise E3 is available through a subscription-based model and delivers Windows Enterprise Edition features. In a subscription-based model, you pay a monthly fee for using Windows, and you don't need to buy them before you can start using them. This offering is available through the CSP channel through the Partner Center as an online service. Windows Enterprise E3 in CSP provides a flexible, per-user subscription for small and medium-sized companies, ranging from 1 to hundreds of users. As with the previous scenario, when a user signs in with Microsoft Entra credentials that are associated with a Windows Enterprise E3 license, the operating system switches from Windows Pro to Windows Enterprise. VDA subscription activation. You can also take advantage of subscriptions to Windows Enterprise for virtualized clients. Windows Enterprise E3 and E5 are available for Virtual Desktop Access, VDA, in Microsoft Azure or in another appropriate hosting platform. To support this, you must configure your VMs to enable Windows Enterprise subscriptions for VDA. Both ADDS Joint and Microsoft Entra Joint clients are supported. VDA subscription activation also supports inherited activation starting with Windows 10, version 1803. It enables a Windows VM to inherit its activation state from the Windows host. When a user with Windows E3 or E5 license creates a Windows VM on their Windows host, the VM inherits the activation state from a host machine. VDA subscription activation requirements. To enable Windows subscription activation, your VMs must run Windows 11 Pro, be a member of an ADDS domain or Microsoft Entra Joined, be Generation 1, be hosted by a qualified multi-tenant hoster, QMTH, such as Microsoft Azure. Inherited activation. Windows virtual machines to inherit activation state from their Windows host. When a Windows user with an E3/E5/A3/A5 license creates a new Windows VM on the Windows host, the VM inherits the activation state. For further details, visit Windows Subscription Activation. Next unit. A provisioning package is a method of applying configuration settings to a Windows 10 or later device using either removable media or downloaded directly to the device. They're created using a graphical tool called Windows Configuration Designer, WCD. Similar to the concept of group policies, administrators use WCD to select options for a specific configuration. WCD then exports a package file containing the settings that can be applied to a Windows 10 or Windows 11 device. You can use a provisioning package to modify a Windows installation and configure many runtime settings without having to reinstall the Windows operating system. For example, you can use a provisioning package to configure the Windows user interface, add additional files or apps, adjust connectivity settings, meet mobile network requirements, manage certificates, comply with security policies, remove installed software, reset the Windows installation to its initial state. Although you can achieve the same result by deploying a new customized Windows 10 or Windows 11 image, using a provisioning package is faster because the file sizes are small. In a provisioning package, you can configure many settings such as computer account, certificates, edition upgrade, folders, policies. For example, by using the computer account setting, you can specify the name for a Windows computer, which domain the computer is a member of, which organizational unit, OU, you want to create the computer account in, which user account you'll use to add the computer to the domain. You can use the edition upgrade setting to upgrade Windows Pro to Windows Enterprise Edition or Windows Education Edition. Upgrade Windows Home to Windows Education Edition without reinstallation. Change a product key. Perform activation by using the edition upgrade setting. Apply runtime settings to a running Windows computer, to an offline Windows image, or during the OS installation. After you configure the settings in the provisioning package, you export the package to a .ppkg file. During the export, you can choose to encrypt the package and sign it. If the provisioning package is signed, you can allow only packages that are trusted to be applied on a client computer. You apply the provisioning package by running the .ppkg file, by adding the provisioning package in the Settings app, or by running the Add Provisioning Package Windows PowerShell command. Provisioning packages can be beneficial for organizations who don't have a more centralized management tool. However, as provisioning packages can be applied offline, they can be beneficial for enterprise organizations in scenarios where internet connectivity is limited or unreliable. Next unit, use Windows Configuration Designer. Continue. Need help? See our troubleshooting guide or provide specific feedback by reporting an issue. Feedback. Was this page helpful? Yes. Use Windows Configuration Designer. 100 XP. 3 minutes. The Windows Assessment and Deployment Kit, Windows ADK, includes a tool called Windows Configuration Designer, which you can use to create provisioning packages. You can use the Windows Configuration Designer wizards to configure the following settings. Expand table. Step. Description. Desktop wizard. Mobile wizard. Kiosk wizard. Setup device. Assign a device name, enter the product key to upgrade Windows, configure shared use, and remove pre-installed software.